okay? It has a virtual impactor which selects for these particles for PM2.5, right? So it basically filters out these bad particles, the particles that we're interested in. It has a thermophoretic precipitator that then expels the particles out of the airstream, okay, onto a mass-sensing element, which is a resonator, a film book acoustic resonator. And basically it's a piece of polysilicon that vibrates, all right? It's a very small piece of polysilicon. Vibrates, and then as these particles get deposited onto that piece of polysilicon, the resonant frequency of that device changes, and we can then figure out how much mass was deposited on it, okay? So I mentioned, before we used microfabrication techniques to make it really smaller. So this is basically the exploded CAD drawing of how this device would look like. We have a top wafer that caps the underlying microfluidic circuit. We have heaters for the thermophoretic precipitator that are actually essentially not printed but deposited onto this top wafer. The wafer is made out of fused quartz. We have the microfluidic circuit, which is made out of etched silicon. So this is a silicon wafer. And then we have a bottom wafer that contains the electronics and the mass sensing resonator. And that's actually being inserted into this microfluidic channel. Okay, this is, again, just a close-up on the device. It's about the size of a small memory stick. You can see we have an inlet hole here. We're actually looking through the top quartz wafer. Okay, so you can see the heaters coming in here. This is the microfluidic channels. We have the inlet hole, the outlet hole. And so the first thing which we have on the path of the fluid flow here would be the virtual impactor. And you can see actually a scanning electron micrograph of the virtual impactor right here.